This is Mitko and today you're going to learn everything about volumetrics in Blender. This is Blender 2.8 3.1, but this should apply for many versions of Blender. And let's open up an example file that I've been working on only a day, but I'll finish this piece. This is the finished piece. This video I want to focus on how you're gonna get that volumetrics look and render it actually in a pretty nice time. So like if you try to render volumetrics, you may end up rendering it 10 hours maybe an image, right? But we want to minimize that render time as much as possible, and I have rendered this piece, which is a really high resolution. I mean, not really high resolution, it's like it's 1440 by 960, and I have rendered it only for an hour and 20 minutes, which is quite a good time. So this is the scene that is in the picture, right? You have a model, you have some bus stop here, some grass. So let's start talking volumetrics, right? First, where do you apply volumetrics? There are two things what you can do. You can apply volumetrics if you open up the shader editor, which I'm gonna do here. There is the option of object shading and world shading, right? You can apply the volumetrics here in the principal volume, and I recommend the principal volume shader because it's faster than applying both the volume scatter and the volume absorption shaders and mixing them up. It's just a much better shader, the principal volume shader, and just applying it to the volume. As you can see, if I go to the rendered view, which the world has fog, right? And there is density, and we're gonna say, let's just for sakes, we're gonna say the same amount of density that the fog has, but you see the samples are rendering really slow. Now, what you can do is make a cube, a simple cube. Let me just bring back to make a simple cube that is encompassing the scene, right? And only there render volumetrics. And as you can see, if I have this, if I go to the if I select the cube object here in object shading, I have the same principal volume shader as here, the 0.35, 0.35, everything is the same, and put it in volume. But if I put on render, you're gonna see that it's much, like not much faster, but it's faster. And that's the most important thing. It's a little bit faster. Do you know why it's a little bit faster? Because, so every time a light ray escapes the camera, it bounces off of the particles, right? And the maximum amount of bounces it can do is found here in the volumes, and there is a max step. This is the amount of bounces a volume would be given, right? But if this camera ray goes outside of the cube volume, it maybe will take like 100 bounces to go outside of the cube volume, and it will know that it's dark, there's nothing there, right? And it will just end the calculations, right? But if you have the world density, the world volume, it will never end. I mean, it will end after 1024 steps, right? Which will always do this, it will always do 1024 step calculation instead of just having 100 steps in the cube, right? So I highly advise make a cube and just encompass the scene. It is much more efficient than the world volumetrics, right? Next thing, volume density is based on the lightings, on the light's positions. So it's based on lighting. And what does this mean? This means that the volume is denser closer to the lights. So if I have this area light here, which is on top of the scene, and why I have put it on top of the scene, because I want the same scene to have the homogeneous density. I've put this area lamp right there somewhere, right? Like in the in here, right? And if you take a look in the scene, right, the area lamp is in the whole scene, right? But it's far away, and this will make the volume here closer to the girl and closer to the bus stop less dense. This is due to the Blender's way of calculating, and the Blender's math doesn't see the volume as a homogenic volume, but it sees it as it just cuts down on calculations when the lights are far away. Hence, you can see that if I show you the picture, this light is very far away, and here is dense to the light. But from here and this, you can see the whole path, right? You can see here the reflections in the road. You can see the can and everything. But close to this light, because this light is very close, this volume is very close to this light, you can see that everything is volume. Like, you can barely see the glass, you can barely see the bus stop, and this is only due to the Blender's calculation. So I highly recommend put the area lamp on top of the whole scene. This will make a very even lighting. Even though this is dark, right? This is a dark scene. You need to have some kind of lighting. You need to light the dark. It's an old saying in filmmaking, right? Another thing is you need to consider branch path tracing, and not consider, always do it. If you go down to the render options, sampling, there is an integrator option, which you need to put. It's by default path tracing. It's all these samples are the same. But if you put a branch path tracing, you can dedicate much more samples on the volume than on the other options. So you don't need really diffuse and glossy if you have the whole scene volumetric, right? This scene is rendered at 4,000 render samples, and I will tell you why. 4,000 render sample times 50, you're gonna have 200,000 volume samples, and you're gonna say, whoa, that's too much. But no, that's not too much for a volumetric scene. That is not too much. And you're gonna see there is noise, but this is the final this is a post-production render. If I pull up the 1 hour and 12 and 20 minutes render, it's really clean, like clean as a whistle. Only here in the lighting section, in the headlights, it's a little bit noisy. But on the other hand, it's clean. And how did I do that, right? And it only took 1 hour and 20 minutes. I did that by using the new adaptive sampling. I've talked about this in a previous video, and they they have done that in Blender, right? I have talked about denoising and helping the denoiser work out, but this is maybe even better, right? So this here adaptive sampling, what it does, it will stop the render of a tile after a certain noise threshold, right? And what this noise threshold is, and how you're gonna set, by default is 0, right? But you would want to set it to some value, which you're gonna find by this trick. So if I go to the camera view, and you want to render first out a little scene, and you want to see how well, I want to see that this region is noiseless, for example. I want to to make this region here noiseless, and then after some certain amount of time stop the tiling, stop the render of each tile after a certain amount of samples. So in fact it won't use the 4,000 samples or the 200,000 volumetric samples, right? It will only use as much samples as it needs to make that part of the image noiseless. So how do you do this? You first you go to the second render, the scene tab, and you select this cropped render region. What this will do, if you click Control and B, you're gonna select a region, this region, for example. Control and B, and now it will only render this region. First, I didn't know about this value here, and I will show you how I got to this value. So 0.004, I recommend actually putting this value and seeing whether or not you're gonna get a good result. But you're gonna see here at the samples, after a certain amount of samples here in this bigger piece, after a certain amount of samples it goes to 4,000. You see 56, 112, 168, it's cleaning up, 280, and it goes to 4,000. So 280 samples, it took 280 samples to clean up this part of the image. Start with a value and then tweak it out. See when the noise is coming clean, but you don't use that much samples, right? And you can put even 10,000 samples, and if the Blender thinks that the noise threshold is passed, it's not going to use that 10,000 samples. It's going to use only, for example, 3,000 samples. Now, in difficult areas like the woman and here, the noises will be higher and will use maybe the whole bunch of 4,000 samples. Maybe if you put 100,000 samples, it will use 100,000 samples, right? So you don't want to really go far ahead. You want to control yourself. But don't worry if the render time first says that it's like 8 hours or 10 hours. It will probably just it will probably go way down. So you do need a powerful GPU. When you set all these things up, there is one more thing that you may or may not know. And if I just close down all of these, it is in performances, in the render tab, performance. And there is things about the tile size. So the tile size is a little bit debatable, right? And if you have set up to something like 256 pixels to accompany, this is done for the GPU. The GPU is better. The GPU it is more performant on higher tile sizes, right? But the CPU is otherwise. The CPU wants smaller tile size. I haven't tried it yet. I haven't tested it out. But the thing that I know is. Don't take this very seriously, and try if you have the time, try to play it out, play with it, but it doesn't actually make a whole performance difference. In fact, I think for the adaptive sampling algorithm, it is much better to have something like 64, something in the middle, than having an auto tile size. Don't push auto tile size or anything like that. I think you're just gonna lose on performance and gain it, but I'm not sure. Some people may correct me. I think that the adaptive sampling is much better done with lower tile sizes, because it can see the noise, how the noise you will need much less samples to pass the noise threshold. So these are the options that you need to set up in order to make volumetrics render the way you want. And I can show you a little the other project I have been just making. It has a lot of lights. So there's cars, there's lights in the windows, there's lights. It's very difficult to render right? And it took me a little bit, something like an hour. It took me to render a nice image, but with adaptive sampling. You don't need to really push the samples as high as you think, but it will need a little bit more post-production, maybe denoising. But don't volumes are really bad for denoising. Don't just slap a denoise node and think you're over, right? You must, if you do that, you must at least consider mixing the denoise node and putting something like a despeckle node and a denoise node together, mixing them up, making something like a lens distortion and glare just to cover up some volumetric light when the volumes are close to the lights, but they don't have enough samples, like the light is very far away, it will make a lot of speckles. So this speckling is really great node for that. These are the things. World versus object. Object, go with an object. Volume density is based on the lighting position. Branch path tracing, it's a must. Must. Adaptive subsampling in a render region that we all explained. And the tile size, just don't really bother with automating the tile size. I don't think that's much performance difference. Thank you guys for watching, and I'll see you in the next video.